My dear friends, our paper today is paper 2, and we are solving paper 2 from February, March, and 2021. We will try to complete whole paper, inshallah, and all the topics here, by the way, are linked with us. There is not a single thing which is not, because from 2022, the syllabus was changed. Okay, so let's see, my dear friends. So this is February, March 2021. And then, in February, March, there is only one variant. For paper 1, it is variant 2, paper 1, mean 1, 2. For paper 2, it is paper 2, variant 2, and paper 3, of course, there is, of course, 1 mark there. So there is not any option of 3 marks. Actually, this paper is conducted in India in February, March, only in India, nowhere else in the world. So let's start. Structured question, and yes. Answer all the questions in the space provided. So complete table 1 by stating whether each of the quantities is a vector or a scalar. So vector has both magnitude and direction, whereas scalar has only magnitude. Size for its complete description, and acceleration is, my dear friends, so vector. So I will be writing here vector, power, only magnitude, no particular direction. Scalar, work is also scalar, only having size. So no need to think a lot, and 2 marks you will be completing in hardly 10 seconds in Rayban. Okay, now the variation with time t of the velocity v of the object is shown in figure 1.1. So this is basically a velocity time graph. Determine the acceleration. Determine the acceleration of the object from time t is equal to 0 to time t is equal to 4 seconds. So acceleration only from t is equal to 0 to t is equal to 4 seconds. It means, see here it is 4 seconds. So we need to calculate acceleration here. And see, this is a straight line. So acceleration is constant. So either you can use v is equal to u plus at, sorry, a is equal to v minus u over t, or simply you can calculate the gradient of this graph and you will get the answer. So anyway, it's correct. Dear friends, so let's calculate the gradient. A is equal to v minus u over t. So that will give us the answer for this one. Okay, my dear. Now, gradient of velocity time graph is equal to acceleration. So acceleration is equal to, I'm writing capital G for gradient, my dear friends, so that we can save time. So capital G represents the gradient. That is basically y2 minus y1 over x2 minus x1. How many marks? 2 marks. So better we should write this one also. So y2 minus y1 over x2 minus x1. This value, my dear friends, if I'm going to calculate this ordered pair, so this is equal to, see, x is 0 and y here, that is 0.70. So x1 is 0, y1 is 0.70. And what about this point, my dear friends? When I'm trying to calculate the other point, that is, x is 4, decided 4, and 1 point, this is 2 boxes below, so 1.4, so x2, y2. So by the way, what is y2? 1.4 minus what is y1? That is 0.70 over 4.0 minus 0. As we are going to simplify, my dear friends, answer I have already calculated, that comes to be 0.18 meters per second square. But see, even my dear sons, what can we do? Another way also, just let me share with you quickly. So this value will be u, initial velocity, and initial velocity is 0.70. Why? How can we know that this is 0.70? See 0.25. and 5 boxes. So each box is representing, small square is representing 0.05. So 0.25 here, see this is 0.5, this is 0.75. So one box small square below, so minus 0.05, so it will become 0.70 simply. And here this is 4 and 1.502 boxes below, it means 0.1 is subtracted, so that will become 1.4. So also we can say that V is equal to 1.4 and then T is equal to 4. So simply you can also do it that A is equal to V minus U over T. So my dear friends, 1.40 minus 0.70 over 4.0, and even then answer will be staying the same, that is 0.18 meters per second scale. I'm sure there will be no problem with this. That is simply, and this is velocity time graph. So the velocity time graph means that acceleration will be equal to gradient of the graph. And if the examiner is asking about the height, which is type of a distance or displacement even, then the area under the graph, but particular portion of the graph, whatever will be told by the examiner. So now, yes, my dear friends, the next question is the distance moved by the object from time t is equal to 0, so t is equal to 4 seconds. So area under the graph. And here, my dear friends, which area we are going to calculate? We are going to calculate the area under the graph of this all area. This side will be equal to A, that is 0.70. This side, my dear friends, this side will be equal to B. And this one, the distance between the parallel sides, this will be equal to H. So this is basically, this shape is basically the trapezium. This shape is basically equal to what? Trapezium. So A is 0.7 up to here we have already calculated. B is 1.40 already we have calculated. And the distance between the parallel sides, that is equal to 4 minus 0, 4. So simply we can calculate the distance traveled, my dear friends. Distance will be equal to area of the trapezium. So 1 over 2 times A plus B, which means sum of the parallel sides, times H, the distance between the parallel sides. So now simply 1 over 2 times, what is A? A is 0.70. What is B? That is 1.40. This is the sum of the two parallel sides times each, that is equal to 4. And as I'm simplifying this, my dear friends, the answer is coming to be 4.2. So the answer comes to be how much? That is equal to 4.2, and already it is in what? Meters. I'm sure this is very simple, but see, don't be fooled here. By the way, don't try to calculate the area of this portion only. No, not at all. Area under the graph. So area under the whole graph till 4 seconds. So that area is basically becoming what? That area is becoming, dear friends, equal to uh, area of the trapezium. Okay, like this side and this side. Now, next is define force. F is equal to ma. But the best way is rate of change of momentum. It is the rate of it is the rate of change of moment. It is the rate of change of what? Momentum. Okay. Now, dear friends, we have to plot a graph. The motion represented in figure 1.1 is caused by resultant force F acting on the object. Of course, there is an acceleration. First positive, then zero acceleration, then negative acceleration. Why I'm saying this? Come here. See here, acceleration is positive in this portion. Up to 4 seconds, 0 to 4 second, positive acceleration. From 4 to 8 seconds, zero acceleration. And from 8 to 12, acceleration is what? Acceleration is negative, but still constant. Okay. So, and also we know by the way that acceleration is directly proportional to the resultant force. So, my dear friends, if the acceleration is constant, it means the force will also be constant. If acceleration is 0 here from 4 to 8 seconds, it means force will also be 0. And then if the acceleration is negative, force will also be negative. But my dear friends, is the gradient of the constant acceleration positive constant acceleration and negative constant acceleration? Is the gradient same? No. If, see, I have calculated the acceleration from 0 to 4 seconds already. So my dear friends, here I'm writing the acceleration uh, from 0 to 4 second we have calculated, and that is, my dear sons, how much? 0.18 meters per second square. Let's check what is the acceleration from here till here. Now, acceleration from 8 to 12. So V minus U. V minus U. V is basically 0. U is how much? That is already we calculated. It is 1.4 over T. And that is how much? 12 minus 8. So dear friends, when I'm calculating this answer, 1.4 divided by 12 minus 8 is 4. So answer comes to be 3.35. 1.4 and 8. So it is, yeah, answer comes to be 0.36. Sorry, 0.235 for me. 1.4 divided by 4. So answer comes to be 0.35 meters per second square. Now, dear friends, see 0.18 times 2, it is 0.36 and it is 0.35. So it means acceleration is almost double. So if the force here is F, my dear sons, very important, if the force here is F in this section, so then the force in this section, that will be 2F. Why? Acceleration is directly proportional to resultant force. If the acceleration from 8 to 12 seconds is doubled, it means the net force, the resultant force, the effective force in it will also be doubled. And in this portion, force is equal to what? Force is equal to 0. The reason for that, because the acceleration is 0. So what to do? Let's draw it here. Now I can take any value. See, if I'm taking this, so its double is not available. Okay. So my dear sons, constant force in the first 4 seconds. Then in the next 4 seconds, body is not accelerating. Graph like this. And then force will be negative because acceleration is negative, and it will be double also. See, here it was 1, 2, 3, 4, 5 boxes. Here 1, 2, 3 till here 10 boxes. So my dear friends, this will be the shape of the graph. But what was the clue here? Clue was the Newton's second law of motion, that acceleration is directly proportional to the resultant force. If any one of you did not get this graph, please, my dear sons, feel free, you can ask me. Muhammad Naji, is that okay? What I have done, this graph I have taken from the previous graph, just calculating the acceleration and then comparing the acceleration with the force. Basically, acceleration is directly proportional to the resultant force. Muhammad Naji, Ahmad Rama, please comment on this, yes, sons. Is that okay?
Okay.
Say loudly. Ah, my voice is also very low to you people. Nobody asked me, sir, your voice is low, because it was below 50%. Yes, is that
It
okay?
sounds fine to me. Yes, it's okay.
Yes.
Ahmad, is that okay with you?
Yes.
Okay. Muhammad Ashraf, Munzir, Talha,
Understood.
Yes. Yes, sir.
Mahad, what do you think? Especially this part, my dear sons, especially this part. Others were too easy.
Yes, sir, I get it.
Okay, let's move to the next question now. What is meant by work done? That's a simple, straightforward answer. So, work done is basically, we know, if a force acts on a body and body covers a distance in the direction of force, that is simply what? That is simply the definition of work done. I'm just using the shortcuts here, sons. So we can write force times distance, or you can write displacement in the direction of force. Only one mark, so that is more than enough in the direction of force. Now next. A beach ball is released from a balcony at the top of a tall building. The ball falls vertically from rest. So u is equal to 0, my dear friends, and reaches a constant terminal velocity. The gravitational potential energy of the ball decreases by 60 joules. It means the loss in GPE is 60 joules. As it falls from the balcony to the ground, the ball hits the ground with a speed of this and kinetic energy this. Okay. Show that the mass of the ball is 0.18 kilogram. So what is the idea coming in your mind, my dear friends, to solve this? Only 2 marks. Speed is given. Kinetic energy is given. So it's quite simple to calculate what? The mass. Only 2 marks. So simply what will we do? We will say kinetic energy is equal to 1 over 2 mv square. Now, my dear friends, kinetic energy is given. How much is that? That is 23. Equal to 1 over 2 times mass we need to find. Speed 16. And don't forget to take the square of the speed. And simply when we will calculate, answer is going to come 0.18 kilogram. So my dear friends, mass will be equal to 0.18 kilogram. Calculate the height of the balcony above the ground. So that is also very simple. Gravitational potential energy is given. And mean this is even not like IPCSE. So my dear friends, potential energy, EP, that we know equal to mgh. Now here we need to calculate height. So EP, gravitational potential energy, that is given equal to 60. It is mentioned here. How much? That is 60. So 60 is equal to mass. We just have calculated 0.18 times value of G is 9.81 times height. So making the height as the subject of equation, we are getting, my dear sons, 34 meters. That's what. Very simple, straightforward. No need to worry about this. But the next question now, I need to explain. And now see, determine the average resistive force acting on the ball as it falls from the balcony to the ground. Now, average resistive force. Average resistive force. Yes, even if it says decreases by 60, so my dear friends, decreases by 60 joules. So either it is loss in gravitational potential energy or it is a gain in gravitational potential energy. Our equation is same, that is mgh. Yes, if they want to calculate the changes, so then we are writing delta EP is equal to mg delta h. That's what we can say. Mahad, what do you want to ask, my dear son, by saying decreases by 60? Is there any particular point? So quickly ask me. If you think that it can be negative, no, it will not be negative, because negative mean a scalar is always a positive value. Vector can be positive, vector can be negative, vector can also have zero value. But energy, any type of energy, that is scalar quantity. And scalars having no negative, it is always positive. If you are thinking like why it decreases, so I should write here minus 60, no chance, never. Now, resistive force. And by the way, we should be a bit logical. Resistive force. Resistive force. My dear friends, see, 60 joules is the loss in GPE, but the gain in KE, it is only 23 joules. Where is the rest of the energy? Almost 60 minus 23, 37, 47. Okay, I will check it. So that is simply this energy is lost against friction or resistive forces. So if I'm applying the law of conservation of energy here, my dear friends, now, first we will calculate the work done against resistive forces, then we can calculate the average resistive force, but quickly. Now see, I will write here that, no, I can write loss in GPE, or I can write change in gravitational potential energy, mean the loss is equal to gain in kinetic energy, plus, my dear friends, work done, and here resistive forces, so work done against resistive forces, or resistive force. That might be a resistance majorly and so on. So now see, this is 60. Kinetic energy is equal to 23. So work done against resistive forces, we can easily calculate. That will be, my dear friends, 60 minus 23, answer comes to be 37. So work done is equal to 37 joules. Now what to do? We know work done is equal to force times the distance in the direction of force. So gravity, so mgh, so force is in the direction of the weight. Basically, weight is the force responsible for this fall. So here, my dear friends, 37 work done against resistive forces is equal to force times what is the distance traveled? That is the fall, 34 meters. So, my dear friends, F will be equal to 34 divided by 37, sorry, divided by 34. So that is almost 1.1 Newton. 1.1. So I'm writing here, my dear friends, 1.1 Newton. If any one of you is having any question or query here, please feel free. You can ask me. Is that okay? No response.
Okay.
Yes.
No problem.
Now, let's move forward now. What is this? What is this? State and explain the variation, if any, in the magnitude of the acceleration of the ball in B, in part B, during the time interval when the ball is moving downward, but before it reaches constant terminal velocity. Constant velocity or terminal velocity. This is also something like IGCSE. My dear friends, if you remember the graph of a falling body, like it is velocity and here it is time. So graph is something like this. My dear sons, initially constant acceleration and then acceleration starting to decrease and ultimately it becomes constant. And now we can divide this graph into three portions. If you ask me, what are the three portions? My dear friend, one is here. 2 is up to here. This is 1, this is 2, and this is 3. We don't need to discuss 3 because here the body is at terminal velocity. Terminal velocity. Before terminal velocity, it is what? It is a ball. My dear sons, in the beginning, as the ball is dropped, its initial vertical velocity is 0. So if you ask, this means air resistance on the ball is also 0. So the only force acting on it, that is weight. So weight is also equal to the resultant force. Please here be very careful. AR stands for air resistance or resistive force, and RF for resultant force is equal to W. So this implies that it falls with acceleration due to gravity. Then, as it is falling down, it is accelerating. It means velocity is increasing. So, in that case, my dear friends, the weight of the body will not be changing. It will stay what? It will stay constant. Whatever the weight before, same no. But as now it is accelerating. So before air resistance was 0, now there is air resistance. Now what will be the resultant force here on this body? My dear friends, it will be decreased. Weight minus air resistance. So resultant force is decreased. Why? Because air resistance is increased. So if resultant force is decreased, we know acceleration is proportional to resultant force. This implies that acceleration is decreased and acceleration is acceleration is less than 9.81, or it is less than g. I hope g. So it is less than g. But up to here we will discuss. Up to here only he is asking before it reaches the constant velocity. So I'm sure you got the concept. And why I'm relating the air resistance, air resistance or drag force, it depends, my dear sons, on what? It depends on uh, air resistance depends on the speed of the body and the area exposed. When the ball is falling down, so its area exposed to the air is constant, so that will not cause any effect. Like when the parachutist is opening the parachute, so area is all of a sudden increased too much. But here that's not the case. So here air resistance will only depend on the velocity. So it is even directly proportional to the speed. If the speed is increased, so the air resistance acting on the same body with the same area exposed to the air will also be increased. Now 3 marks are there. First of all, I think we should talk about the three valid points. My dear friends, I will say, see, explain, state well, if any magnitude of acceleration during, okay, they didn't talk about the forces, okay? So what I will say that initially, my dear sons, A is equal to G. Acceleration of the ball is equal to acceleration due to gravity, because, yeah, and I have written also there, the resultant force is equal to weight. As a resultant force is equal to weight. So when speed of the ball increases, when speed of the ball increases, air resistance also increases. So resultant force equal to weight minus air resistance decreases, or you can say net force decreases, and acceleration of the body decreases. That's what you can write here, my dear. It is, if you have a good concept from IGCSE, so this is almost IGCSE stuff like that question. So I'm sure this will be not a problem. You can just keep in your mind this graph also to answer this question, and then I have explained you, and only up to here we have to talk about, because then the body reaches terminal velocity and we have to answer the acceleration just before terminal velocity. Dear sons, if this question was that state and explain the variation, if any, in the magnitude of acceleration in terms of forces, even I have mentioned here now weight is there, air resistance is there, but it will be better in that case. You should start your explanation. The forces acting on the ball is weight downward and air resistance upward, and then the explanation you can start further. So start with mentioning what are the forces which are acting on the ball. So this was question number 2. I think that is done, alhamdulillah. Now come to question number 3, and that is about spring and something like that. A spring is extended by a force. The variation with extension x of the force F is shown in figure 3.1. Now see, this statement looks like very complicated, and this is simply the variation with extension x of the force. So the variation of the force with extension, even it is more simple. That is the style which we are using, which we were using and taking the questions in IGCSE physics. Nothing special, same thing. Now, in such cases, be very careful. See, force is in Newton. My dear son's extension is in centimeters. So if he is asking K any moment or energy, and it will be 1 over 2 Fx. So then, because energy you will write in joules, so this x which is in centimeter, it must be converted to meters. If he's asking some way to calculate K, the spring constant, stiffness constant, that is f over x. So also we need to calculate this x, sorry, convert this x from centimeters to what? To meters. Okay, and let's start now. Here, my dear friends, state the name of the law that relates the force and extension of the spring shown in figure 3.1. Hey, yes, my dear sons. Again, this is IGCSE. What is the name of the law?
So,
Yes, Munzir, very good. And what about the others? Kulonom? Yes, my dear sons, it is. This certain name, Hooke's law. And even very next question can also be, why this graph obeys Hooke's law? What will be the answer? Muhammad Ashraf, Mahad.
Can I say?
Yes, yes,
Okay.
yes, why not?
It's a straight line, so that starts from the origin.
Yeah, exactly. Exactly, yes, son. I was going to get a shock if you were not going to say it through the origin. Because in the beginning, I worked a lot with you people. You are all the time writing, I know in the homeworks that gradient is constant and this and that. No, that is okay. Gradient constant, 1 mark. That means straight line. You have to say it is passing through origin. Very good. Nice. Stabilized. Now next, see and even see the spring constant in Newton per meter. So F is equal to Kx and then K will be equal to F over X. So gradient of the graph, like you can take this point. What is this value? This is 5. And here, my dear son, see this is 1, 2, 3, 4, 5. So that is 5 and here it is 7. And this point, you know, this is 0 and 0. So even change in force, difference in force or gradient, whatever. So force is how much, my dear sons? That is 7 over x, which is 5. And if you will do like this, you are going to lose marks. This is simple, wallah, sadaqah jariya from Cambridge. They just want to give you the marks. Straightforward, simple. And if you're not converting it from centimeters to meter, big mushkil. So, my dear friends, I have done it already. So when we are calculating the answer, I think it is 140. So yes, 140 newtons per meter. Unit is written. Here unit is written, but all of a sudden you will find that there is a question, no unit is there. So cross check. Newton meter, written. Okay, no need. If not written, then you have to write Newton per meter. Not Newton meter, sorry, Newton per meter. Strain energy, elastic potential energy in the spring when the extension is 4 centimeters. No, not 5. Extension is 4 centimeters. Here it is 4 centimeters. And my dear sons, this one is x. And then the value of, sorry, this should be the value of f. So how much is that? See, this is 4, in the center 5, 5.2, 5.4. So that value of force is how much? Sorry, that value of force is coming to be 5.6 newtons, my dear sons here. This force is 5.6 newton, here it is 4. And you know, either area under the graph or 1 by 2 even kx square. We can do both the things now. We can do both the things now. Area under the graph, that is 1 over 2 fx in this case, because base into height. So base is 4 and height is 5.6. That is okay. Or maybe Muhammad Ashraf, maybe Talha, maybe Muhammad Naji is thinking, sir, there is also 1 over 2 k, 1 over 2 kx square. That will also be workable. Why? Because already we have calculated the value of k. In both the ways it's okay. And then making the square of x, even then you will get the same answer. But I will go with the straightforward first point, that the elastic potential energy, that is equal to, in this case, 1 over 2 f into x. So my dear sons, 1 over 2 f I have shared already with you, that is 5.6. See, they said 4 centimeter. Here also you need to wake up. 4 centimeter, not at 5 again. So 4 alatul straight up. You will use the ruler, and better in exam you should draw the dotted line. They will be more visible to the examiner. Dotted lines, they will be more visible to the examiner because you will be having the ruler, and you are supposed to carry with you people at least 15 centimeter long rule in theory papers. And when on 28th of April you will be moving to the exam, it is recommended that you should carry 30 centimeter rule, because in question number 1 definitely there will be a graph, and that graph you have to draw almost the greatest whole page. So small, you know, the one of the mark is the continuity of the graph. So if you are using a smaller scale and then connecting it, that will disturb the continuity of the graph. No, so it should be long scale with you on that day. So 30 centimeter scale. In general, in lab, it is available. You can ask the lab attendant at that moment, but better not. It is better not to waste time asking him. Carry your own that transparent ruler of 30 centimeter length with you people. Anyhow, so here, my dear sons, here 1/2 F is 5.6. That is in Newton, but X is in centimeters. So 4 divided by 100. So instead of divide times 10 raised to power minus 2. And when I'm simplifying it, my dear sons, I'm getting the answer 0.11 almost on roughly. So 0.11 joules. That is the strain energy, straightforward till now. Next is then, yeah, from here bit tricky, but not that much. It's okay. One end of the spring is attached to a fixed point, a cylinder that is submerged. A cylinder that is submerged in a liquid is now suspended from the other end of the spring. No, I did not make the connection. I lose the connection. Sorry. So again, I will read. One end of the spring is attached to a fixed point. Okay, here is the fixed point. A cylinder that is submerged in a liquid is now suspended from the other end of the spring. Okay, other end of the spring, and then, okay, done. Fine. It's okay. Now, spring's extension is 4 centimeter. Okay. Cross-sectional area, see, this is not System International. This is not SI. Again, we need to convert it later on, wherever we need it. Cross-sectional area, well and good. That is in meter square. Perfect. Weight, it is okay. And the length of the cylinder, that is 5.8 centimeter. This is also not in SI. Not SI. Now, the cylinder has a length of 5.8 centimeters. Yes. Cross-sectional area this and weight this. The cylinder is in equilibrium. Cylinder is in equilibrium. If the cylinder is in equilibrium, then, my dear son, the sum of the forces on it will be 0. The resultant force on it will be equal to 0. Resultant force on this cylinder will be equal to 0. So, the extension of the spring is 4 centimeters. Show that the upthrust acting on the cylinder is 0.6 Newton. So upthrust we have to show, answer we have to give. So now, my dear, only 1 mark. I remember when I solved this question first time, I was surprised why it is 1 mark. It is not that much simple or straightforward question. Now, upthrust formula, which mostly we teachers are sharing, we are saying that it is equal to, okay, U is equal to rho, density of the fluid, volume of the object times G. That is the formula. But problem here is we are not given with the density of the fluid. And I was thinking to do it this way, but the density of the fluid is asked in the end, in the last part of the same part B or yeah, part C. So then what to do? Then we need the forces acting on this cylinder. So my dear friends, what are the forces? Weight of the cylinder is acting downward. Upthrust, it will be upward, because upthrust is always upward. Upthrust is upward, and there is also tension in the wire, that is also upward. So as I told you, my dear friends, as I told you already, that the cylinder is in equilibrium, resultant force is 0. So it means we need U plus T minus W, it should be equal to 0. This is a trick. That's why I'm not convinced that it should be 1 mark, at least 2 marks. Upthrust is always upward on an object when it is submerged in a body. So I maybe told you last class also, my dear friends, that there are 2 forces about which the direction is confirmed all the time. That is clear. Weight is always vertically downward, and upthrust is always in an opposite direction to the weight of the body, that is upward. So tension, in that case, this spring is stretching it, pulling it upward. So that is the tension of the spring. So tension is upward in this case. So 2 forces upward, they will be added up, and weight is downward. Now we have weight, but we don't have tension. Don't worry. This spring extending by how much? 4 centimeter. And my dear sons, at 4 centimeter, what is the force? That is 5.6. And this force is now what we will call it. We will call it a tension force for that particular part. So all the forces are with us now. So simply upthrust we need to calculate. So upthrust will be equal to basically W minus T. And my dear son, W is 6.0. So 6.20 minus that is 5.6. And as we simplify, you can check answer comes to be 0.60 Newton. So this answer will come in terms of forces. We cannot use this formula because we don't have the density with us. Density is not given to us. So we cannot use this formula to calculate the upthrust. Please, dear friends, any question, any ambiguity, any doubt, feel free, you can ask me. Now, next I will be moving, calculate the difference in pressure. That difference in pressure will be because of the difference in depth between the bottom face and the top face of the cylinder. Bottom face and top face, face of the cylinder. Bottom face and top face of the cylinder. You know, upthrust is equal to difference in pressure. Upthrust, that is equal to difference in pressure times area. Difference in pressure times area. Upthrust is a force. And now here, my dear friends, see, one force is from top to bottom, that is from the water pushing this cylinder down. So let this force be F up. You know, they said up or top here between top. Okay, Ft. I will write this Ft, top force at the top direction. So Ft. And there will be this water will be pushing it upward. This will be force from the bottom, Fb. Okay. Now, why did I write upthrust is equal to change in pressure times area? My dear sons, pressure is equal to force over area. Now here on this cylinder, what is the resultant force acting? That is equal to the upthrust. So upthrust, I can Fp will be equal to U over A. So then we can write U is equal to P into A. But between the bottom face and top face, there will be difference of pressure. At the top face, pressure will be lower because depth is less. And from the bottom, you know, at top face, the depth is this one. We can call it H1. And here the depth is, this is H1 and this one will be H2. So due to difference in depth, there will be difference in pressure. So that's why, my dear sons, I have written it like, you can tell me, so I can write delta P, difference in pressure will be equal to U over A, and then U is equal to like this. Okay, so now I will be placing the values here, my dear friends. What we need to calculate? We need to calculate simply delta P, which will be equal to difference in pressure, okay, delta P, that will be equal to U over A. Now, my dear friends, what is U? That is 0.60. And what is area? Area was given 1.2 times 10 raised to power minus 3. 1.2 times 10 raised to the power minus 3. And I know answer will come 500 Pascals. But wait, let me confirm it. 12 5 is 60. It looks to me okay. But even then, let me confirm. So 0.6 over 1.2 times 10 raised to the power of minus 3. As I'm simplifying it, so answer comes to be 500. Please, my dear sons, is that okay with you people? Especially this part now. Both these parts were tricky, but even this part and this part, are they, did you understand them? Please, everybody.
Yes.
Respond.
Teacher,
Yes, yes, my dear.
Understood.
how do you get the tension?
How to get the tension? Yes, 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 my dear son. See, it was mentioned. So when this cylinder is underwater or in fluid, so extension produced in the spring is how much? That is 4 centimeters. That is how much? 4 centimeters. Now, my dear sons, extension 4 centimeter, that, you know, when there will be extension produced into the spring, so that there will be tension also. force also on this. So we can go back to the graph. Here it is the 4 centimeter, then dotted line fold up till it touches the graph, and then, my dear, here, see, this tension is how much? Already we have calculated. That answer came to be 5.6 Newton. So Ahmad, my dear son, tension from the graph this way by making use of what? Extension. There was a purpose why the extension was given. That was given for calculation of tension in that particular scenario. Is that okay?
Yes.
Yeah, this was Munzer, sorry. I thought F1. No problem. Sorry. Okay, now calculate the density of the fluid. No, that's very simple. Density, pressure is equal to rho GH. Now we have pressure, we have G, we have the difference in height also. I will tell you what is that. So we can use, my dear friends, even you can use up thrust is equal to rho. Two ways are there, my dear sons. Even we can use, okay, first of all, pressure, difference in pressure we calculated is equal to rho G delta H. Okay. So this will be equal to change in pressure over rho delta H. So change in pressure just we calculated up there, your sons, how much? That is 500 over value of G, that is 9.81 times delta H. Now, what is delta H? That is the difference in height. My dear sons, see, I have already tried to explain here. So difference in height, that will be equal to H2 minus H1. So see, H2 minus H1 is equal to this one. So that is equal to difference in height. Please try to get it again. See, H2, that is from the surface of the water to the bottom of the cylinder. H1 from the surface of the water to the surface of the cylinder. So what is the difference in height? H2 minus H1. That is the length of the cylinder basically. But again, we need to be very careful. It is in centimeters and we should convert it into what? Meters by multiplying with 10 raised to power minus 2. My dear sons, is this difference in height clear to everybody?
Yes.
Yes.
So now just we will be writing the value here. 5.6 times 10 raised to power minus 2. Very important. That is in centimeters. So when we are simplifying, I think answer came to be 880 for me. But let me check. This was 880. Yes, exactly. It is 880 kilogram per meter cube. Now, one thing more, my dear sons, here. You can also do it this way. You may think, we have upthrust. So density of the fluid, that is liquid, times volume of the object times G. Upthrust we have calculated. How to calculate volume? Very simple, my dear sons, here. For this cylinder, pi r square h, area is given already and height is also given. But you have to convert the height into what? From centimeters to meter. So density we can easily calculate because upthrust we have already calculated. Volume we can get simply by multiplying the area with the depth. AH for a cylinder, volume of the cylinder is pi r square h. H is also given, but in centimeter we will convert it into meters. So my dear sons, I'm 200% sure that this formula will also give us the density, and that is U over V times, sorry, V out time volume of the object times T. Now there is one query that is, okay, Mahad, no problem. If you have a class, you can leave. Okay. You are fasting, so pray for us, pray for you, pray for your friend, and pray for my this class also for best grades, inshallah. You can leave the class, no worries. Mahad is fasting, actually, my dear sons, so he wants to leave. So that's why I'm telling him to pray for us all. Okay, the liquid in C is replaced by another liquid of greater density now. Maybe before it was water, now it is honey. Before it was water, now it is milk. Something like that. So state the effect, if any, of this change on the upthrust acting on the cylinder. Now, my dear friends, what do you think? What will happen to the upthrust if the density is more? I'm just waiting, my dear sons, for your response, and you should answer it very good way.
Increase.
Yeah, sorry. What did you say?
Increase.
Exactly, it will increase. My dear son, I will write increases. Always try to answer by C. I just did it here right now. What is upthrust? Upthrust is equal to density of the fluid. I'm writing like this: fluid times the volume of the object, V capital, times G. Now, my dear sons, volume of the object, it was before sphere, now it is also sphere. Before it was cylinder, now it is also cylinder. Volume will stay same. Value of G will stay same. It means upthrust in this scenario is directly proportional to what? It is directly proportional to uh, uh, density of the fluid. So it is still underwater, under fluid. So if the density is increased, yes, and the upthrust will also be what? Increased. The extension of the spring only they said state. No need to go for explanation, but little bit explanation we will do so that this is very clear to us. Now, the extension of the spring. So if density upthrust is more, so this extension will be less. It looks to me, you know, my dear friends, what to do here. So I will write here decreases and I will explain you. Just give me a moment. Decreases. Reason. Now see here, my dear sons, this body was in equilibrium, so it is still in equilibrium. So then we wrote before, there is one equation which I used, that u plus t minus w is equal to 0. U plus t minus w is equal to 0. So I'm writing the same. T plus u minus w equal to what? 0. Resultant force should be equal to 0. So here it is 0. Now, my dear friends, set the effect, if any, on the extension of the spring. Extension is caused by this tension. That's what I used. 4 centimeter. Extension is caused by this tension. Let's calculate the tension force, my dear friends, here. So that will be equal to W minus U. Now, my dear sons, already in the upper portion we discussed that U is increased. So it means tension is decreased. If tension is decreased, tension is the force causing extension. Tension is the force which is causing what? Which is causing extension. So, my dear sons, extension will be decreased. This way you can write the answer. They did not ask you to explain, but I have written it. So if in your exam to explain it, so you can go this way. Please, if there is any query, any question, feel free. You can ask me. Is this okay with everybody?
Yes.
Muhammad Naji, where you are, my dear friend?
I'm here. Sure. Okay.
Okay, Alhamdulillah. Ahmad, Talha, are you sleeping?
I said yes.
No, sir.
No, sir. Okay, fine. Okay, let's see my waves now. Principle of superposition. What is this? This is again and again. So when two waves superpose, their resultant displacement is the sum of their individual displacement. That's what. Please, this is so common. Two or more waves overlap, superpose, even you can say overlap. So their resultant displacement is the sum of their individual displacements. individual displacement overlap. There, sorry, yes, sir, are the either at the resultant displacement. That simple definition, no need to worry about that. Now, a transmitter produces microwaves. Here is the transmitter producing microwaves that travel in air towards the metal plate. My dear son, the microwaves, they are the second longest wavelength. The longest wavelength is radio, second longest is microwaves, as shown in figure 4.1. Now, here is the receiver and metal plate. The microwave has a wavelength of this. So lambda is given and that is already in meters. A stationary wave is formed between the transmitter and the plate. Stationary wave. So explain the function of the metal plate. My dear sons, you know how this stationary wave is produced? When two waves identical in all respect. Meaning what? Two waves with same amplitude, same frequency, same wavelength, whatever, travel along the same line but in opposite direction. They give rise to what? Stationary waves. So what is the function of this metal plate? This will be reflecting the stationary waves. Simply what will be this doing? It will be used for the purpose of what? Reflection. So its function is to reflect. Reflect what? Don't say micro stationary waves. It is basically first microwaves. Straightforward. This is the answer here. Because stationary waves, that is a clue. Stationary waves are produced by reflection of the waves. So with conditions, that's what I told you already. So simply it is used, its function is to reflect the microwaves. Only one mark. Calculate the frequency in gigahertz of the microwaves. My dear friends, no problem here, but 3 marks. I'm so much surprised. V is equal to F lambda. So F will be equal to V over lambda. And we should be very clear that all types of electromagnetic waves, radio waves, microwaves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. These are the second components of electromagnetic waves. All are transverse, all move through air and vacuum with the speed that is 3.0 times 10 to the power 8 meters per second. It was nowhere mentioned, but we know that microwave or radio or infrared, visible light, ultraviolet, X-rays and gamma rays, they travel through vacuum, they travel through air at a speed of light. That's what we have used. Now wavelength is already given to us, my dear sons. So 0.040 meters, and units are already system international units, so no problem at all. So simply we will calculate it and we will be getting the answer. So when we are calculating it, answer comes to be 7.5 times 10 raised to power 9 hertz, and 10 raised to power 9 means, my dear sons, giga. So simply here write 7.5 times 10 raised to power 9. No need to write because it is already in gigahertz. I'm sure you are with me and it's clear to you. Anybody having any problem here? Is that okay to everybody?
Yes.
Yes.
Okay.
Yes.
Now come. This is very simple, by the way. Now quickly. A microwave receiver is initially placed at position X, where it detects an intensity minimum. You know, when it is minimum intensity and it is a stationary wave in the beginning told, so it means that this is node over there. Determine the shortest distance from from X of the receiver when it detects an other minimum intensity, mean another node. So the shortest distance from one node to the other node, this is only 2 marks, 1 mark here and 1 mark here, it looks to me. And one thing is very clear, my dear friend, at X node. So the distance to the very next node, minimum shortest distance, wavelength is given. And you know, we know one thing. Wait a minute here. Let me draw, my dear sons, here. Something like this. You know, not good always to draw these sprays. So like this. You know, this point, this is a node, antinode, node, antinode, sorry. Node, antinode, here, antinode, node, antinode, node, antinode, node, antinode, node, antinode, node, antinode, node, like this. And you know, my dear sons, the distance between two consecutive crusts wavelength, distance between two consecutive successive neighboring troughs wavelength, distance between two consecutive compressions in terms of sound waves or longitudinal waves wavelength, distance between two consecutive rarefactions of the on the sound wave or on longitudinal wave wavelength. But in case of stationary wave, this is the only type of wave where the distance between two consecutive nodes or antinodes is lambda by 2. Is what? Lambda by 2. So it means, my dear sons, here, if you ask me from this node to this node, this distance will be equal to what? Lambda by 2. So that's what I'm going to do. So D is equal to what? Lambda by 2. And they want uh, distance between, so 0.040, so 0.040 divided by 2, so answer will be 0.02 meters. Am I right? Is this okay? So the distance between one node to the next node, that will be lambda by 2 from node to the next node. So in this way we can get it. So very simple, distance from one node to the next node is lambda by 2. Now, see, my dear friends, determine the number of intensity maxima. Now he wants antinodes. How much? He wants what? He wants now antinodes. That are detected by the receiver as it moves from X to a position 9.1 centimeter away from X. 9.1 centimeter away from X. Okay, so, okay, first of all, this is in meters, you know. So the distance, okay, let me make it this way. 1, 2, 3, 4, 5, this way. See, from here till here, this one distance has come up there 0.020 meters. You know, this is 9.1 centimeter. So, my dear friends, in terms of centimeters, how much it will be? So, it will be equal to, I think, 2 centimeters, because we multiply this 0.202 with 100. Wait a minute. 0.02 times 100. Answer is 2 centimeters. So, my dear friends, my dear friends, wait a minute. So determine the number of antinodes that are detected by the receiver as it moves from 9. Okay, see, this is 2 centimeter. This is also 2 centimeter. This is also 2 centimeter. Here also 2 centimeter. Here also 2 centimeter. Check. 2 plus 2, 4 plus 2, 6 plus 2, 8. No, this is 10. So it is 9.1. My dear sons, if you ask me, actually this distance will be 9, more than half. It means this one will be equal to, according to that standard, 9.1 centimeters. So count the number of intensity maxima, antinodes, 1, 2, 3, 4, and 5. So simply answer will be 5. That's what you have to do, my dear sons. Please, if any one of you has having any question, query, doubt, feel free, you can ask me. Is that okay with everybody?
Yes.
So this you will just convert in from meters into centimeters. Next now. A source of sound is attached to a rope. Okay, here is the source of sound attached to a rope and then swung at a constant speed in a horizontal circle as illustrated in figure 5.1. So two questions from sound. So the radius of this circle is given 2.4 centimeters. So it is going this is going anti-clockwise. The source moves with the speed of this. So speed of the source means Vs that is given. Then my dear friends, and a sound of frequency, this frequency is also given. Then the speed of the sound in the air is this 330 meters per second. Okay. An observer standing at a very long distance, here he is standing the observer away from the source, here's the sound, calculate the minimum frequency to the three significant figures of the sound heard by the observer. Of course, we need to draw or we need to apply what Doppler's effect. Now, my dear sons, we know one thing. At this point, here, see its direction, it is moving away. And at this point, it is moving towards. So when it is moving away, it means the wavelength is increasing and frequency is decreasing. So frequency is minimum at this point. And when it is moving towards, so wavelength decreases, frequency increases. It means frequency is what? Maximum. Okay. Now they want three significant frequency by the when it is moving away. See, it is mentioned what? The sound heard, the sound by the observer. So the source is moving away, so it means we need to take this point. So when it is moving away, how can we use the Doppler's effect? If you remember, my dear sons, observed frequency FO is equal to V over V plus Vs times Fs. So moving away, denominator is added, velocities are added. Moving towards, this same formula but V over V minus Vs. Moving away, so denominator will be added. If it was moving towards, then it was reverse opposite. So my dear, let's just place the values to get our answer. See here, the speed is 330 for the sound over. So 330 plus 12, this source, times the frequency is 951. And as I'm simplifying, answer is almost 918. And we said answer should be three significant figures. Three significant figures. Only you have to just decide either it will be denominator V over V plus Vs or V over V minus Vs. So if it is moving away, plus in the denominator, moving towards, minus in the denominator. Now the circular path of the source has a radius. This radius is given. Determine the shortest time interval between the observer hearing the sound of minimum frequency. And this is very simple, my dear son. You know, they want us to calculate basically how much time will be taken in this semicircle, half circle. Okay. So simply V is equal to distance over time. In this case, if it was a complete circle, then it was 2 pi r. But right now, it is half a circle. So simply pi r over t. This implies that t is equal to pi r over v. T is equal to what? Pi r over v. So pi as it is, r is 2.4 and that is in meters divided by V, that is 12. And as we simplify, my dear friends, the answer comes to be 0.63 seconds. 0.63. Pi times 2.4 over 12. Answer is 0.63 seconds. Mean we have shortest interval between the observer hearing the sound of minimum frequency and observing the maximum frequency. That's what I told you already, my dear sons. When it is over here, frequency is minimum. And when he is here, frequency is maximum. So it means we need to calculate the time taken for the semicircle. For him to travel along the semicircle, sorry. So we have to calculate the time taken for him to travel along the semicircle. So formula of speed, which is equal to distance over time. And in this case, as it is a semicircle, so distance will not be equal to 2 pi r. It will be 2 pi r over 2. Basically pi r. So I wrote directly pi r over t, then making t as the subject of equation, placing the values, and we are getting the answer, my dear friends. Now the next question. Kirchhoff's first law. Again and again, the same question, my dear friends. So that simply sum of the currents entering a junction should be equal to the sum of the currents leaving a junction, or sum of the currents at a junction is equal to 0. I wrote last time also this way. Sum of the current is 0 at a junction in a circuit. First class, 1 mark only. So that is enough. At a junction in a circuit, my dear. Now, electromotive force, EMF of 12 volt and internal resistance R. This time internal resistance is there. So there will be lost volts across R is connected to a filament lamp and a resistor as shown in figure. Now, my dear, the current in the battery is 3.6 ampere mentioned, and the current in the resistor is 2.1. IV characteristic for the lamp is shown in figure. And one thing we know, if this is 3.6, this is 2.1. So what will be this? So the current here will be 1.5 ampere. The reason, because 3.6 minus 2.1, that is equal to 1.5 amperes. Anyhow, so characteristic curve is given. Now that is volt, current against the volt. So my dear, what we are supposed to calculate? So first of all, determine the resistance of the lamp in figure. Resistance of the lamp in figure 6.1. Resistance of the lamp in figure 6.1. So now, my dear friends, as I did already, so current in lamp, first we can calculate current in lamp, that comes to be 3.6 minus 2.1. So we can write it is equal to 1.5 amperes. Now also potential difference across the lamp we need to know. Potential difference across lamp. How can we calculate it? How can we calculate it? My dear sons, come here. Again from the graph, current is 1.5. This is the IV characteristics for the lamp. So at 1.5, this one, my dear son, C2 divided by 10, so 0.2, so 4.2, 4.4. So current potential difference across the lamp will be equal to how much? 4.4 volts. Then resistance of the lamp, R is equal to V over I. So 4.4 divided by 1.5. So answer is, my dear sons, equal to 2.9. I'm sure it is not very difficult. It's okay. But 3 marks. See, 1 mark for the calculation of current. This is the value which I have calculated from what? From graph. Please, my dear son, be very careful about this. Okay. Now determine the internal resistance of the battery. Internal resistance of the battery. You know, for that we know the formula that E is equal to what? V minus I small r. V is the terminal potential difference, which is across the length. Now total voltage is how much? That is 12. We calculated potential difference across the length. That is 4.4 minus current. You know, this internal resistance is within the battery and the current in the battery is 3.6 times R. Let's go back, my dear friends. In the diagram, see, internal resistance is here. That This internal resistance is in series with the battery. So whatever is the current in the battery, same will be the current in the internal resistance, because internal resistance is connected in series with the battery, and in series through each component, current stays the same. So 3.6. And when, my dear sons, I will be just simplifying it for the internal resistance, I'm going to get the answer 2.11. So R is coming to be how much? 2.11 ohms. Okay, so this is very important formula whenever we are dealing with the EMF. So actually, what is the terminal potential difference? Why did I subtracted IR from V? Come here in this circuit, my dear friends. So whatever is received by this lamp or this internal resistance, that will be after the voltage lost is subtracted. You know, some of the volts are lost through this resistor, across this resistor. So we will subtract that. Whatever is left, that will be then through the lamp and also through the this resistor. So that's what we did, my dear sons, making R as the subject of equation. You can get the answer. Now the next question is, the initial energy stored in the battery is 470 kilojoules. Assume that the EMF and the current in the battery does not change, do not change with time. Calculate the time taken for the energy stored in the battery to become 240 kilojoules. So energy in the battery to be reduced when the, of course, it is being used up. So the energy will be reduced with the time. So now we have to calculate the time. Now, my dear friends, first of all, what can we do? We can calculate, time. In general, in physics, time, basically current is equal to Q over T. Then T will be equal to Q over I. So if we can calculate Q, we can easily calculate, I is already there, so we can easily calculate the time. So first of all, we know that EMF is equal to energy transferred over energy transferred per unit charge. So what is the EMF of the battery? That we know, 12 volts. Energy transferred, see, from 440 to 240 kilojoules. Be very careful. Don't forget to write here kilo. Over Q, my dear sons. And when we will make Q as the subject of equation, we are going to get 19166.7 column. So now we have charge. Just place the values here. It will be 19166.7 over I. Current is how much? Current in the battery is 3.6. And as we simplify it, my dear sons, answer comes to be 5324 seconds. So if we want to write it in two significant figures, we can write it 5300 seconds. 2 marks, but in 2 steps we can do it. So if there is any problem, any doubt, please feel free. You can ask me. I'm waiting for your response, and just give me 5 minutes more. Inshallah, this paper will be completed. So any question, any doubt, please feel free. You can ask me.
Yes, sir.
It's clear?
Yes.
Okay. What about Muhammad
Yes.
Hadi?
Yes.
Okay.
Good.
Alhamdulillah. The filament wire of the lamp is connected in series with the adjacent copper connecting wire of the circuit as shown. Okay, they are connected in series. Mean this is copper and this is filament wire. They are in series. It means currents through them will be same. Some data for the filament wire, this wire in and the adjacent copper wire connecting wire are given in the table 6.1. Filament wire area of cross section is A and number of free electrons, number density is N. Here current is 360 ampere in copper wire and number density is 2.5 N, mean 2.5 times more than filament wire. Calculate the ratio of average drift speed of free electrons in filament wire over the average drift speed of free electrons in the copper wire. You know, my dear sons, transport equation. I is equal to N A Q V. V is the drift speed. So here if I'm making V as the subject of equation in general, so V will be equal to I over NAQ. Now let's place these values, my dear sons. So here I'm solving it now. So that was simply transport equation, also we call it our current equation. So I is equal to NAQV. N is the number density, A is the area, Q is the charge carrier charge, and V is the drift speed, and I is the current. So now, my dear friends, I have made V drift speed as the subject of equation. Let's place the values here for electrons in the filament wire. Okay, so I will be just placing the values directly. So my dear friends, current I over N. You know, in filament wire, it is N as it is, area A as it is, and charge Q as it is over average drift speed in of free electrons in copper wire. I as it is. Why I'm taking I as it is? Because they are connected in series. So whatever the current is flowing through the copper wire, same current will be flowing through the filament wire. They are connected in series over N. It is not N now. In copper wire, it is 2.5 N yesons times area. Here area was A, but here area now 360 times 60A times Q as it is. Now, my dear sons, very simple. I cancel with I. N cancel with N. A cancel with A. Q cancel with Q. So now what is left behind? By the way, at the top, it is only 1 over 1, and here 1 over 2.5 times 360. And you know, denominator is basically numerator. So this ratio will be 2.5 times 360. So that was a simple question, by the way. So if we multiply them, dear friends, if we multiply them, we are getting the answer 900. So 360 times, sorry, 2.5, answer is 900. So my dear son, the ratio is equal to how much? 900. Just straightforward. I don't think there is any problem. Okay. So, but this formula, you have to first manipulate and then accordingly you can move forward. And why current is I have taken same. This is a series circuit, and in series circuit, current is staying same through every component. Now, the last question of nuclear physics, and that is comparatively very easy. The results of the alpha particle scattering experiment provide the evidence for the structure of the atom. So the result one is the vast majority of the alpha particle, they pass straight through the metal foil in gold foil. So, or are deviated by small angles, and result two, a very small minority of alpha particles is scattered through angles greater than 90 degrees. So state what may be inferred, mean deduced from result one. Most of the atom is empty, very common. IGCSE stuff, by the way, this one. But they went straight. So most of the atom is what? Most of the atom is empty. Only 1 mark, so that is okay. Next is 2 marks, so we have to write 2 points. My dear friends, what can we write? The central part of the atom is charged. Central part of atom called nucleus. That is what nucleus is charged. This is one thing. And you know, if they are reflected from more than 90 degree, one thing, repulsion is there. Secondly, there is something massive which is repelling them, which is reflecting them. So and most of the mass is concentrated in nucleus. Most mass So there are 2 marks, so you should write these 2 points. Most mass of atom is concentrated in nucleus. My dear sons, these 2 points you can write for 2 marks. Nucleus. Now, a radioactive decay sequence contains 4 nuclei P, Q, R, and S. See, P, Q, R, and S. As shown, nucleus S is isotope of nucleus P. Determine the proton number and the nuclear number of this S. Now see here. This is an isotope. If this is an isotope of P, so proton number should be same. Proton number should be what? Same. So my dear friends, even we can say one thing. There is a decay. So 84 to 82, you know, charge number is decreased by 2. It means here it was alpha decay. Here it was what decay? Alpha decay. 82 has become to 83. So it means there is beta decay, but beta minus decay. And then 84, 3 has become 84. So it means again there is beta minus decay. Okay, so this nuclear number, it will not be affected. It will stay 214 because when beta is decaying, beta has negligible mass. So 84, if you ask me here S, that will be same 214. So it will be here also 214. So if you are maybe a long time, so you know from IGCSE 6C14, it is converted to nitrogen 7N14 plus beta, my dear son. See, 7 minus 1, 6. So here 83 to 84. So here 6 to 7. But at the top here it is 14 nuclear number, here also 14 because there is beta decay. So same is the case here. So it will be 14. So proton number of S, that will be 84 because it is the isotope of P. So isotopes of an element are the atoms with the same number of protons but different number of neutrons. See here neutrons, nucleons are 218 and here 214. So nuclear number for S, that is 214. Nothing special, very simple. Now he's saying the quark composition of a nucleon in Q changes as Q decays to R. Q to R. You know when beta is decaying, actually what is happening? Beta minus decay. If you ask me, I have told you beta minus decay, my dear friends. It is because one neutron in the nucleus, it decays to one proton and one electron, which is beta particle. Now see, charge is 0 plus 1 minus 1, 0. Charge is conserved. Nuclear number or mass number is 1. Here 1 plus 0, 1. So what is happening? A neutron is decaying to proton. And what is the quark composition of neutron, my dear son? That is UDD. And when we talk about proton, that is UUD. Electron, no quarks, because it is elementary charge. So, my dear sons, they said quark composition. So, what I'm going to write? I will be writing here change to quark composition of the nucleon. So, one down quark changes to one up quark. You may be thinking, how? See, this down is cancelled by down. Okay, this up is cancelled by up. Basically, what is happening? Down to up. That's why, my dear sons, I wrote here one down quark is changed to one up quark. Only 1 mark. No need to go for explanation, but I have explained you how this all had happened. Yes, my dear sons. Any question here? Please feel free. You can ask me.
No questions.
No questions.
Understood.
Okay.
Understood.
Stay blessed, my dear sons.